Hello students, in last session we completed up to second number. Now we go for third number. Same question is repeated here. We need to find a quadratic polynomial. The two numbers are given. First number is the sum of zeros and the second number is the product of zeros. First number, sum of zeros is equals to 0. And the second number is the product of zeros is equals to root 5. All 6 questions are same as first two. First of all, we are assuming two zeros. Let alpha and beta are zeros of required quadratic polynomial p of x is equals to ax square plus bx plus c. In this question, first we need to find the coefficients a, b and c using the sum of zeros and the product of zeros. Divide the page into two parts. Left hand side taking sum of zeros. Zeros are alpha and beta, then sum is alpha plus beta, and the product of zeros is equals to alpha into beta. Now alpha plus beta and the value of alpha and beta are given. Alpha plus beta is 0 and alpha into beta is root 5. Sum of 0 0 and the product of zeros is equals to root 5. We have to put here is equals to 0 and here is the root 5. See, nothing in denominator, then we put 1. Both denominators are equal according to alpha plus beta is equals to minus b upon a and alpha into beta is equals to c upon a. See, both denominators are equal, then go to next step. Alpha plus beta containing minus a single time. Here no minus is available. That's why we have to put minus 0 upon 1. Here 0 is not a number containing 1, 2, 3 like that, so that one time minus is enough. 0 upon 1, root 5 upon 1. Both the denominators are equal. One minus is here, so that it look like as minus b upon a and here is the c upon a. Now a, value of a, value of b and value of c. Both denominators are equal. A is equals to 1, minus with minus and b is equals to 0 and c compare with the numerator, c is equals to root 5. Therefore, required quadratic polynomial p of x is equals to ax square plus bx plus c. Now we have to substitute values of a, b and c. Here a is equals to 1, x square as it is, plus b is equals to 0, x is it is, and c is equals to root 5. 1 multiply x square gives x square. 0 multiply x is 0, then not need to write in next step, plus root 5. Here x square plus root 5 is our required one quadratic polynomial, but we know there are infinitely many quadratic polynomials. There the sum and the product of zeros are 0 and root 5. As we know, in general, required quadratic polynomial P of x is equals to k into bracket this polynomial x square plus root 5, where what is k? Where k is non-zero integer, or again we can write in form of in the symbolic form. Symbolic form is k belongs to r minus 0 is also true. Now the next fourth number. In the fourth number, two numbers are given. We know as the first number we have to take sum of zeros is equals to 1, and second is product of zeros is equals to 1. Again 1 is the common sentence in all. Let alpha and beta are the zeros of required quadratic polynomial. P of x is equals to ax square plus bx plus c. Again divide a page into two parts. Left hand side we have to take sum of zeros, and the right hand side is the product of zeros. Method are same in all. First is sum of zeros is equals to alpha plus beta, and second is the product of zeros alpha into beta. Alpha plus beta and alpha into beta is given here. Both are 1 1. Here is the 1 and here is also 1. See, nothing in denominator, then we have to put here 1 upon 1 is equals to 1 upon 1 according to the two conditions. Both denominators are equal. First condition is proved here. Now the second condition, alpha plus beta is equals to minus b upon a. Here is no minus, that's why we multiply 2 times as a minus, 1 outside minus and 1 in the bracket, minus minus plus, and it will becomes again 1. Now it is look like as minus b upon a and is equals to c upon a. Now comparing a, b and c with the above terms, and we get values of a, b and c. Both numbers are equal. A then 1 1, a is equals to 1, then b minus with minus, and b represent this bracket minus 1, and c is in numerator, c the numerator, c is equals to 1. Therefore required quadratic polynomial P of x is equals to ax square plus bx plus c. Now we have to substitute the values of a, b and c. Instead of a is equals to 1x square, instead of b is equals to minus 1, x as it is, and instead of c is equals to 1 multiply x square gives x square, plus minus minus 1 multiply x gives x, and last is plus 1. Here the x square minus x plus 1 is our required quadratic polynomial whose sum of zeros is 1 and whose product of zeros is also 1. In general we have to write many and the lots of quadratic polynomial. In general required quadratic polynomial is same right here, x square minus x plus 1, but multiply with k. But what is k? Where k is non-zero integer. Value of k should be belongs to R but not a 0. Let's verify this polynomial is correct or not. X square minus x plus 1, it is our rough work. X square minus x plus 1, here a is equals to 1, b is equals to minus 1 and c is equals to again 1. First of all, we need to find sum of zeros. Alpha plus beta is equals to minus b upon a. Minus, we know what is the value of alpha plus beta given in the question, which is 1, and the product of 0 is also 1. Minus, instead of b is a minus 1, instead of a is equals to 1, minus minus plus 1, 1 upon 1 gives also 1. Thus the 50% question is obtained here. Alpha plus beta, sum of zeros is equals to 1. Alpha into beta is equals to c upon a, where c, what is c? C is equals to 1, and again a is equals to also 1, but 1 upon 1 is equals to again 1. The second part is obtained here. The product of zeros is equals to also 1. That's why our obtained polynomial is 100% true. Both sum of zeros is equals to 1 and the product of zeros is equals to also 1. We verifying bottom to up. Here is our polynomial and it is our question. It is a question from the obtaining polynomial. It is not a part of solution. It's just a verification, how to verify our polynomial is correct or not. Got it? Very well. In next session we will discussing remaining 2 sums in the question number 2 from exercise 2.2. Students, let's see last 2 sums of question number 2. Same method will be repeated here. 2 numbers are given. First number is the sum of 0 and the second number is the product of zeros. First number is the sum of zeros and the second number is the product of zeros. Sum of zeros is equals to minus 1 upon 4 and the product of zeros is equals to 1 upon 4. First sentence same in all. Let alpha and beta are the zeros of required quadratic polynomial p of x is equals to ax square plus bx plus c. We have to find the values of a, b and c by using the sum and the product of zeros. Make the 2 parts. Left hand side take sum of zeros is equals to alpha plus beta. Right hand side the product of zeros is equals to alpha into beta. The sum and the product of zeros are given here, minus 1 upon 4 and plus 1 upon 4. See, both conditions are satisfied in the given questions. Both denominators are equal and alpha plus beta containing minus, which is minus b upon a. alpha plus beta is equals to minus b upon a. Alpha into beta is equals to c upon a. Both denominators are equal and alpha plus beta having minus a single time. It look like as minus b upon a is equals to c upon a. Now we comparing minus b upon a with a bottom and c upon a with a bottom, and we get values of a, b and the c. A denominators are equal, 4, 4, a is equals to 4. B minus with minus, then b is equals to 1, then 1 is here. C numerator contains c, then c is equals to 1. Therefore, required quadratic polynomial p of x is equals to ax square plus bx plus c, where a is equals to 4, x square as it is, plus instead of b is equals to 1, x as it is, and instead of c is equals to also 1. 4x square as it is, 1 multiply x gives plus x and plus 1 as it is. Here 4x square plus x plus 1 is our one polynomial in which whose sum of the zeros is equals to minus 1 upon 4 and the product of its zeros is 1 upon 4. In general, required quadratic polynomial p of x is equals to k into bracket obtained polynomial 4x square plus x plus 1, where k is non-zero integer. There are lots of polynomial are obtained here whose sum and the product of zeros given as per our question. Now last one, two numbers, first is 4 and second is 1. First is sum of zeros. Sum of zeros is just for our understanding is equals to 4 and product of zeros is equals to 1. Same process will be repeat here. First sentence is same. Let alpha and beta are the zeros of required quadratic polynomial p of x is equals to x square plus bx plus c. Same thing, we need to find the values of a, b and c here. We make two parts. Draw a line between the page. Left hand side we write sum of zeros is equals to alpha plus beta, and right hand side product of zeros is equals to alpha into beta. We know both values, sum of zeros and the product of zeros, from the given question. Sum of zeros is equals to 4 and the product of zeros is equals to 1 is equals to 4, and right hand side is a 1. Now see, nothing in denominator, then we have to put compulsory 1, 4 upon 1, and here is the 1 upon 1. First condition is satisfied here. Both denominators are equal. Yes, they are equal. We are making here a equal. Now alpha plus beta is equals to minus b upon a. Here minus is not available. Then we multiply numerator 2 times as a minus. 1 minus is outside the bracket and 1 minus is inside the bracket. Minus b upon a and is equals to c upon a. On comparing minus b upon a and c upon a with above term, we get the values of a, b and c. Now a is equals to, numerators are equal, a is equals to 1, b is equals to minus with minus. Then what is the value of b? Can you understand? What is the value of b? b is equals to minus 4. And c is equals to, numerator c is equals to 1. Therefore, required quadratic polynomial p of x is equals to standard form ax square plus bx plus c. Now we substitute the values of a, b and c in this standard form. Instead of a is equals to 1, here is a 1, x square as it is. Instead of b is equals to minus 4, it is a minus, then put into a bracket minus 4x, and instead of c is equals to 1. Is equals to 1. Now we simplified it. 1 multiply x square gives x square, plus minus minus 4 multiply x is 4x and plus 1. It is our one polynomial whose sum of zeros is equals to 4 and the product of zeros is equals to 1. In general, there are lots of polynomials are obtained. In general, required quadratic polynomial p of x is equals to x square minus 4x plus 1, where k, here k is available within multiplication form, where k belongs to r minus 0 or where k is non-zero integer. Both are true in sentence or in symbolic form. Now k into bracket x square minus 4x plus 1 is a lots of polynomial whose sum and zeros given according to the condition. Let's see one example for that. Suppose here the value of k is 2. Then we multiply bracket with 2. 2 into bracket x square minus 4x plus 1. Then our polynomial is 2x square minus 8x plus 2. One polynomial is x square minus 4x plus 1. Second polynomial is 2x square minus 8x plus 2. Lots of polynomial we are obtaining here by putting value of k, different values of k. Here a is equals to 2, b is equals to minus 8 and c is equals to again 2. Now for this polynomial we have to find sum and the product of zeros. Sum is alpha plus beta and product is alpha into beta. Now we know the formulas of alpha plus beta and alpha into beta. Alpha plus beta minus b upon a. Alpha into beta is equals to c upon a. Now we substitute the values of a, b and c from this polynomial. Instead of b is minus 8, minus as it is, instead of b is minus 8, and instead of a is equals to 2, minus minus plus 2 4s are 8, then our answer is 4. Sum of zeros is 4. See in question, yes it is a 4. This polynomial is also true. alpha into beta C upon A, where C is equals to 2, C is equals to 2 and A is equals to 2. 2 upon 2, 2 cut and we get 1. Yes, alpha into beta means the product of zeros is equals to 1. Hence the second polynomial satisfied the condition given in the question. The sum of zeros is 4 and the product of zeros is equals to 1. Again, you have to try more polynomials and verify yourself. In this session, question number 2 from exercise 2.2 is completed. In next session, we will be go through a next topic.